Hi, I am Pim, and I will guide you through this tutorial. In the previous tutorial, we looked at SOAP web services. In practice, however, REST web services are used more often than SOAP web services. So in this tutorial, we will look at how you can use WEM to access a REST web service. First, we look at the difference between SOAP and REST. Then, we look at how REST web services work. And after this theoretical background, we will dive into the functionality WEM offers to use REST web services. Let's get started. Here, you can see the main differences between SOAP and REST. The main difference is that SOAP is a real protocol. All elements are fully defined. REST, on the other hand, is merely a set of guidelines. Every developer creating a REST web service decides for himself how to apply these guidelines. One of the consequences is that with SOAP, you have a WSDL file exactly describing the web service. This file is machine readable, which allows WEM to import the interface definition of the web service. With REST, on the other hand, there is only human readable documentation in which a developer can see how the guidelines were applied. WEM is not able to read this. So as a WEM developer, you have to feed WEM with this definition yourself. Another main difference is that the SOAP protocol is quite heavy in its implementation. REST, on the other hand, is relatively light. As a result, in traditional development environments, SOAP is more difficult to use than REST. That explains why REST is more popular than SOAP. Although SOAP is easier for WEM to handle, WEM has found ways to make using a REST web service quite easy as well. This is where a famous statement by Albert Einstein applies. Everything should be made as simple as possible, but not simpler. The idea behind this is that if you make things simpler than possible, you will miss out on possibilities. And that is not what we want. WEM has turned applying this Einstein statement into an art. WEM makes everything as simple as possible. In such a way, however, that all possibilities remain within reach. You will hardly experience any limitations. Let's see how WEM applied this to REST web services. As said, REST is merely a set of guidelines. This means that every developer of a REST web service has full freedom in choosing how to implement it. As a result, there is a wide variety in how REST web services operate. There is one common element, however. All REST web services use the HTTP request protocol. Let's take a look at this protocol. The HTTP request protocol was originally created to allow web browsers to connect with web servers. When you enter a URL in your browser, the browser will send an HTTP request message to the web server. This message contains three elements: a request line, a set of request headers, and optionally a request body. The request line consists of a method followed by the URL you have typed. The request headers are used by the browser to supply browser-specific information to the web server. And, depending on the used method in the request line, a request body is required. This request body can contain a larger block of data. The web server responds by returning an HTTP response message. This message also consists of three elements: a status line, a set of response headers, and a response body. The status line contains information about success or errors when processing the request message. The 404 message you encounter from time to time when browsing the internet is typically a code that is returned through the status line. The response headers are used by the web server to supply web server specific information to the web browser. The response body contains a larger block of data, usually the HTML that is used to display the requested web page. But it can also contain other data, for instance a block of JSON or XML data. Now, how is this used to constitute a REST web service definition? The different elements of a web service are mapped on this protocol. These elements are operations, input fields, output fields, and fault notifications. Just as we have seen with SOAP web services. Operations are mapped on the combination of a method and a URL, provided through the request line of the HTTP request message. Input fields are mapped on one or more of the following options. Input fields can be mapped on query fields. These are the name-value pairs, provided through a URL, after the question mark. Input fields can also be mapped on request headers. And finally, Some REST web service developers require input fields to be passed as a JSON message through the request body. Output fields are also mapped on one or more of several options. Output fields can be mapped on response headers. And quite often, output fields are mapped on the response body in the form of a JSON message. That is why these REST web services often are referred to as JSON web services. And the last elements of a web service, fault notifications, are mapped on the status line of the HTTP response message. Now that we have seen how the HTTP request protocol is used by REST web services, let's see how WEM uses Einstein's statement to make this available as simple as possible. And the solution actually is really simple. WEM provides a separate HTTP request node for this. With this node, the HTTP request and response can be fully configured. Here you provide the URL. Here you select the method to be used with the URL. Query fields can be included in the URL, but the easier way is to use this Edit Query Field button. Here you can configure the name-value pairs, providing the name for each query field, and an expression calculating its value. And in a similar way, you can use the Edit Request Headers button to configure the request headers. Here you can provide a text field, which contains the request body. For the response headers, you can use the Edit Response Headers button. Here, you can configure the names of each response header, and which field should receive its value. And here you can provide a text field, which will receive the content of the response body. And finally, below here, you can configure fault notifications. For each of the fault code, you can create an exit to this node, which can be used to handle the related fault situation. Now let's take a look at how this works in practice. That always starts with the documentation provided by the developer of the web service. As an example, we will look at the REST web service provided by the Open Movie database. When we scroll down, we see that there are two operations. One for retrieving data and one for retrieving posters. We will give the first one a try. Looking at the URL, we see that an API key needs to be provided as a query parameter. You can request such a key for free. When we scroll down further, we see a number of parameters we can provide. We will try out the search function. The documentation tells us we need to provide a search string through the S parameter. The question is now, how should we provide this S parameter to the web service? When we look at the URL, the ampersand suggests that remaining parameters also need to be provided through query fields. So, let's give that a try. To save some time in this tutorial, I already created a data model. We start with creating an interaction node, which allows the user to enter part of a movie name. We will use the entered value as input for the web service. Now we can configure the HTTP request node. We start with entering the URL from the documentation. Note that we leave out the query fields. We need to select the GET method. Next, we need to set query fields. We start with the API key. I use the one I requested earlier. If you want to try this out yourself, please request a key of your own, and don't use my key. Otherwise my key might get blocked as a result of overusage. Now we need to configure the search parameter. The documentation tells us we need to add a query field S for this. We assign the name field we used in the interaction node. We conclude the configuration of the HTTP request node with connecting the JSON field to the response body. This way, the web service result is captured in this field. To finish the REST web service call, I often use a two-step approach. I start with a temporary interaction node, which displays the bare web service result. We simply drag the JSON field on the screen definition. This will display its bare content. Now we immediately test the web service to see what result it returns. Let's type born to find all the Jason Bourne movies. And here we see, we have a result. This is a JSON message, containing information about the requested movies. For the second step in finishing our web service call, we copy the resulting JSON. We now add an import node, which we will use to retrieve the movie data from the JSON message. We drag the JSON field to the data source property of the import node. Here we click Create from Example. By pasting the copied JSON message, we allow WEM to derive the structure of this message. Now the only thing we need to do is connect the appropriate fields to this structure. Don't forget to connect the data list itself to the array in the derived structure. An array is represented by block brackets. If you omit this, the import node does not know where to add rows for the imported data. We finish our application with an interaction node, showing the imported data. We conclude with updating the application flow. We don't need the temporary interaction node for showing the bare JSON anymore. Time for the final test. As you can see, the REST web service has provided us with information on all Jason Bourne movies. This concludes this tutorial. I hope you liked it. We are happy to receive your feedback. And we are open for any questions you have. You can contact us at support@pim21.com.